Once we do this algorithm, the value of P, phi, and phi. And to learn this one, what is given to the system is set of observations. The signal or symbol emitted by the system is given to the algorithm. Based on these symbols, the algorithm is going to learn the parameter. So there are a number of challenges here. What we mean by the term P is matrix. It represents the probability of transition from one step to another. Probability of transition of what? The hidden change. The usual practice is that if we want to identify the matrix of the chain, what we do? We run the chain for a long time. And then we count the number of transitions from a particular state to another state. For example, we run the chain for 1,000 steps. 1,000 times. Now, out of these 1,000 steps, the chain is in state I, say 100 times. Now, if there are say n steps in the chain, then among these 100 transition from I, some of the transition will be step 1, to step 2, step 3, step 4, step 5, and so on. So based on this, let's say from step I, the transition from I to J is zero. Once we have this together, then we know that probability of transition from I to J is zero. To calculate this, what we need, the chain, the states of the chain should be different. However, in case of a hidden Markov chain, the Markov chain is what we have only the symbols emitted by the system available to us. However, what happens? All the symbols actually are somehow connected to the system. For example, in case of Bill's mode, what we know? When Bill's mode is good, if the weather condition is very probability is high, 0.6. If it is say cloudy, then it is 0.3. If it is say rainy, then it is 0.1. So based on that, a connectivity exists, but we cannot actually say based on this observation, the probability of transition from this state to this state will be this one. So our objective is, based on this observation, how can we learn that this is the perfect one? Now, if we see from very upper layer, then we will see when we change the value of lambda, what will happen? The value of P, phi, and phi will be changed. And this probability will also be changed. If we want to train the system based on this observation, set of observation, which model will be the best one? Which model will best suit the observation? The model for which this probability will be. So what we can do, you can consider that there are 1,000 different possible values of this one. From this model, you can individually calculate this probability. From this 1,000 models, for each of the models there is a probability, and now we find a particular one, then you can say this model is. This one actually is not good algorithm. So a algorithm should be what? We need to start from some. We need to start from some actually initial parameter values. Then we need to calculate the value of the parameters P, phi, and phi in such a way so that every step we will get a better probability, and so eventually there will be a situation where the probability will not be changing. Right? When the probability will be not changing, even though you are repeating the algorithm, but the probability remains very close. At that time, we can know that the algorithm is converged, and this becomes the star becomes the optimal optimum model for this, not for this system, for what? This model is optimum for this object. So we could train the model in such a way it can best represent the. In case of any machine learning model, you know, when you change the data, the model changes and your accuracy level varies. That's why there are two accuracies, right? Training accuracy and validation, many other things. So our objective here is very simple. We want to start with a particular model. Usually what happens, there are two options. One is you can start randomly, or you can have some prior knowledge about the system that you can be able to set the values, and from that basis you can start. Either way it can work. Second thing is that in each iteration we want to get a better. Usually it will be better. So now we will try to learn the algorithm, how this bomb pulse algorithm actually find a particular value of the solid. Second thing is that we will not start randomly. Instead, we will consider the lambda that we already used for the forward, backward, and the return approach. We will be using the same model. Using the same model actually helps us what? The same calculation will be just reused. Our objective is not to model the system. Our objective is to learn how to train the model. How can we train the model? Okay. So, any question? Our first objective is to in this iteration, what we do? We find a new value of b, new value of 5, and new value of r. And when we have a new set of model, let's say this model is called this one. Based on this model, again we calculate this probability. Which probability? Not this one, this probability. That probability should be. And we want to see what is the difference between the previous one and the current one. For example, the probability of the current model is this one, and the previous model is this one. If the difference is less than a very simple number, then we say that the algorithm already converges. So to learn the algorithm, actually we need to find out a new set of values for p, phi, and pi from what? From only this observation. Question is, how can we set this? What is P? P is the transition probability matrix. Right? Then we need a way so that we can calculate this one. How can we define this one? We already talked about this, right? We need to know how many transitions occur in the system where we actually end up in state I. That means if this is state I, how many times we visit state I? And among those visits, how many times we have a transition from I to question is, how can we find it? Again, based on the knowledge that we have about the ASML, is it possible if the observations are independent? Can we calculate how many times the system visited state I, and among those times, how many times there was it? Every time the system visited state I, there is a condition from I to another state. Maybe self-condition or any other state. Now, we need to know how many times there was a transition or there is a condition from I to B. If we can find this fraction, probability, or exact number, or some expected values, then we can calculate the probability in I. We are wondering, since the exact numbers are not available, what we can do? we can find out some expectations, some fractions, some probabilities. Right? To do that, what we do, we define two variables. One is gamma. Let me first tell you what does gamma Ti represents. Gamma Ti represents that probability that the observed signal is O1, O2, up to O2, and at time t distance is I. This gamma t is telling that we exactly observe this sequence of steps. We can consider any example. For example, previous example in last class we have considered an observation sequence like this. 1 and 3x, 1 and 3x. So it says that the system actually imitates these symbols x, y, and x, and also at time t, the system begins with I. This is the variable gamma t is equal. Based on that, what we can find out how this variable can help us. Very important question answer is what is it? What this variable represents? Gamma 1 I. It represents that the system actually observed the cell sequence and at time 1 the state is, since this is the probability, what does it represent? The probability that the chain is turning state I and follow this. So if you can calculate for all the states, then we can come up with this one. Yes or no? Yes. So now the second thing is that for this one, we define another variable. What is this character? Forget about the quality of the handwriting. What is this character?
Sami Jama.
Okay. The die I say, this represents what? This represents probability that the observed sequence is O, that is this one, and rotates 1 sequence. Observed symbol sequence is O, that means this one. We observe this symbol sequence, and at time t, state is I, and at time t plus 1 the state is. How these two variables can be calculated, this is the one thing. Second thing is that we need to identify how can we calculate these two probabilities from just this observation. This is one thing. Second thing is that once these two variables are available, values of these two variables are available to us, how this can help us to calculate this p and phi. So there are two steps associated here. One is how can these two variables be actually আমার ধারণা এটা হয়ে গেছে। My expectation is that because in the morning I have the medicine and then I can do finish sentence. So existing.
So hungry. So hungry.